So the third case study, and this is that case study where we did that, was an auto PD frequency data set. And we had 4 million observations. And each observation represented one vehicle for one policy under static conditions. So again, we split the records based on if there was midterm cancellations or changes in the underlying characteristics. We split the data 70-30 between training and test data sets. We had a total of 58 predictors. And what we did was because of CART, we split the data set based on single vehicle policies and multiple vehicle policies. You can see that more than half of the policies were single vehicle policies, about 2.4 million of them. And we found 17 significant predictors. And on the multiple vehicle policies, we found 13 significant predictors. CART was what told us to segment that data. And now, when we looked at frequency, how do you handle frequency in CART? When we have observations, each individual observation has a separate sort of exposure to it. What we did is we included exposure as a predictor and let it split on that. And so we weren't actually going to be using the direct output of CART for, again, we're not using it for predicting frequency, but we're going to use it to learn about sort of what variables it found to be important. And on the single vehicle policies, it found 31 significant predictors, and 12 of them matched emblem. And it found another 31 as well on the multiple vehicle policies. Not a surprise there, since it's besides single and multi policy, you would think that the predictors would be pretty similar. And 11 of those matched emblem. So from that, we actually we went forward with that, and we started with 34 predictors in the initial model for the single vehicle policy, and we whittled that down to about 20 predictors in our current model. And on the multiple vehicle side, we got down to about 15 predictors in the current model. The key point here is that certainly CART helped us identify additional variables that we didn't initially see or initially threw out when going through some sort of process in our GLM process. So it did help us sort of increase the number of predictors than we would have initially started with, because in the GLM we would have only started with 17 or 13 and reduced from there. Another use of that we see for using CART is what we call super profiling. And that's a situation where you can build a GLM model and then use CART to model the residuals to find out if there's any pattern in those residuals that still exists. And then if a pattern is discovered, you can go back to the model structure and incorporate those findings. It's a nice test to see whether or not your model structure sort of oversimplified your data set. That was all we were going to talk about in terms of the information. What I can do now is pull up emblem and just show you real quickly one of the data sets. So here's the case study 1 data set. And if I just show real quickly sort of the data set. On the left side of the screen, it's just showing the terms in the model. So it just has the various predictor variables that are over here. A graph of the predictor variable where the yellow bars represent the volume of data in terms of weight, which in this case the weight and the number of observations are going to be the same for a retention model. And we have a number of statistics that show up in this particular box over here, and a graph here that can just show us what our predictive variables are for the various levels here. NCD? It's number of years with accident-free. So just cycling through a particular variable's rating area, which is some sort of territory, the vehicle category. And actually what I have shown on the graph is sort of the before and after we've done a little bit of simplification and smoothed out that pattern. The age, NCD, driver restriction, vehicle age, change over last year's premium, and market competitiveness. And so, again, using various techniques, we're able to kind of evaluate what the observation looks like in the data, and then superimpose some sort of simplification that reduces some of the volatility in that data. This is for retention, yes.
So the change over last year's premium was not advantage.
I'm sorry?
The change over last year's premium.
Mm-hmm.
It looks like it's master. It's really so it's the premium, obviously the premium goes up to it becomes
Yeah, and I really don't remember. I know there might have been some sort of cleansing of this data again. What these buckets represent, I'm not sure. I don't remember what they represented. It may have just been numerical, and that was the reason why we were able to use the data set.
Down the borders below represent the number of records? In the
Yes.
range?
Yeah, the number of records in each range. So for vehicle age, we have a lot of vehicles under 9 years of age, but certainly when you get out to the older ages, you don't have a lot of data. And if I put standard error bars on there, you can sort of get an idea of sort of where the volatility is within each predictive variable.
Did you split any data and compare your predictions with outsample data?
We did, yeah. I don't think I have the data here. That might be the test data here. That might be what was fixed on it. I could go through. Let's see here. Let me just open up. Let's see what happens. It's quite a while that we did this, but let me see what happens when I open. Let me just first do this. Excuse me, well, I don't have that. Let's see if I have the. Let me just open this back up and see if let me get this the other way around. Here we go. That's what I want to do. So this should be a comparison of the test data on the predictions, where the blue line represents what our predictions were and the green line represents what happened on the test data. And so if I just go through these, I noticed this when I was looking at this before. I don't know why the age, in this example that we had here, I don't know why the age didn't follow the decreasing pattern we saw here from 1 to 3, because there was certainly a pattern evident in the original data. NCD, driver restriction, vehicle age wasn't in there, and still looks like it doesn't have any value. Change over last year's premium seemed to still follow that curve, and market competitiveness as well seemed to follow that curve. So that was pretty much the extent of that modeling process. I think what we'll do after lunch is Mikhail will get up and talk about sort of what he did. We'll pull up the data in CART and actually run it through and evaluate and take a look at it. So with that, I guess we'll stop for now and we'll start again in another hour and a half.